How's it going, everybody? In this video I'm going to be talking about the LTSpice assignment that's due this week in lab. So the first thing you're going to be doing, if we look at the assignment, is you're going to be answering this question on transformers and RMS voltage. This schematic was taken right out of the lab manual, and all of these questions can be answered from there. So the next thing is the basic diode IV curve you're going to be plotting. So if you look over here in LTSpice, this is the schematic you're going to be doing. So you want a 5-volt DC source, and then you want this diode. So when you click diode, you can click D. D will bring up a diode. You can also go edit component or click F2. And somewhere in this list, I guess if I click diode, there it is. And you can place one like that. So when you place a diode, and I'll place one up here, it'll have this generic D, which I think is an ideal diode, or at least one that LTSpice considers ideal. So basically it's not an actual diode. You can't go out and buy this one. So what you need to do is you need to make it a diode like this guy, and this is a standard diode. You could go out and buy it from any circuit manufacturer that sells it. It's the IN4148. So if you right-click the diode when you place it on the schematic, you can click Pick New Diode, and I believe the IN48 is right here. I just clicked a real easy one, so make sure it's that diode when you make the schematic. Otherwise, your answer probably won't be correct. So be sure to do that, and then just hook it up. Also, something to be aware of is I like to use this notation where I connect grounds not together, but I put them at the bottom. So remember, this would be the same thing as if I connected this wire from here to here, and then just had one ground, right? So just be aware of that. So this is a circuit I want you to build, and then I want you to edit the simulation command, so you do that up here. You're going to do a DC sweep. Your source is V1, so actually I guess giving this voltage, it doesn't really matter, just give this anything to start with, it won't actually matter. So then V1 and linear sweep is fine, starting at 0 volts, going up to 10 volts, and increments of 0.01 volts, so this increment will let you see some subtle differences in how the voltage, the IV characteristic changes. So after that, you're going to click Run, and I don't want to click anything yet because that'll kind of give you the answer, but basically on this curve you can see right at the bottom, this is the V1, so it's going from 0 to 10 volts, and you want to find the current through the diode. So basically what I would do is I would just click right here, and that would plot the current, and it would come up here, but I don't want to do that for you because I want you to do that. So a couple things to be aware of. Remember, make the diode the right number, and also have it go in the right direction. If you do it in reverse bias, it won't be correct. So make sure it has the right orientation. And then you do the DC sweep with the V1, and that should be everything you need for this question. There's also a bunch of thought questions in here, so as well as some analysis questions. So take your time with that. And then rectifier circuit. So the next one, I was going to have you build this, but I don't think that would be a good use of your time. It's kind of a complicated circuit for right now. So I actually designed this circuit for you, and I'm going to post this schematic online. So when you're using LTSpice, you know that if you save a file, it saves as a .asc, and that's just the extension of the file. I'm going to post this file to Polylearn, so you do not need to make this. If you want to try it on your own, it would be a good exercise because it's a fairly complicated circuit, at least for what we're doing in this class. So if you want to, go build this on your own, you can, but certainly double check it with the one I've posted and make sure all your nodes are connected properly. But this is a simple rectifier circuit, and actually it's the same circuit. Let's see if I can find it real quick. That's in your lab manual. It's this circuit right here. So it's actually you're going to be doing this in section 3. The only difference is the diodes won't be the same. But honestly, it'll probably perform almost identical to the way it's going to in lab. So this is going to be a really good exercise because it's going to give you results to compare to when you do the lab experiments. So going back here, like I said, I will provide the schematic. It has everything ready. All you have to do is click Simulate and Run. And I don't know which plot I'm using. Let's close out of all this other junk. Sure. So what I want is I want the voltage across R1. Now notice, it's very important, I have a typo here. It's important that you notice that there's no ground associated with this R1. Normally this bottom edge would be grounded, but it's actually not. It's not even, you can see here it's a little confusing. It's not connected to ground. It goes right past this node and connects right here. So the only way to find the voltage across this is to actually use the math function of LTSpice. So you're going to do that by clicking the voltage. Well, actually, I'll just prove this to you. This is not ground. I can click the negative side of the voltage, so I'll click here, and I'll click the positive side as well. So notice this is out positive and out negative. And then bring this up and you can see out negative is not ground. It's actually a sinusoidal waveform that's blocked off by the diode. So if you understand how a rectifier circuit works, you notice that in the positive going half we have this, upwards, we have only the positive peaks, and in the negative going half we only have the negative peaks, and this is because of that rectifier circuit. So the way we do this is to get the difference in these two waveforms. We do controlled control, and actually you don't have to hold control. You just right click anywhere on this page, and it'll pop up this window, and then you want to go add trace, and this will bring up all the options for things that you can plot. So what I want to plot is V out. So if you click V out, you can also type it in, and then come down here and click minus, just the simple minus sign, and then click V out negative. So this is going to do V out positive minus V out negative, and this is the difference across that resistor. And if I click OK, you can see, boom, it plots it up here. And let's delete those other two. Well, actually, no, let's leave them for now. So you can see this red is the V out positive and V out negative. So this does exactly what I would expect with a full bridge rectifier. It makes all of your peaks, it makes all of them positive. So instead of having a positive peak and then negative and then positive, you only have positive peaks. And that's very important because this is what we need, because direct current is only a positive voltage value. So this is important, this is what we want. And notice here that you're taking the difference. So you're taking this curve minus this curve. So obviously this is a little bit above 0. So that difference here is seen here, right? That makes sense. This one's slightly more confusing. So why is this positive when you have a negative? And the reason is because you're taking the blue waveform and subtracting the green waveform from it. So you're subtracting here negative voltage. So this is like negative, I don't know, negative 0.5 minus negative 9, it looks like. So that'll pop up here, and that makes this guy positive. So it's a negative minus a large negative, and that makes it positive. And then similarly, positive going, negative going, positive, etc., etc. So that's all I want you to do for that. And let's see, I really just want a plot showing this. So this is actually a really easy question. I recommend trying to build this circuit on your own. Perform the exact same, do everything that I did here, and then run my simulation and do this again and compare that you got the same results. So just a good exercise, but if you don't want to do that, you can just simply click run for this guy, and then you just need to do this math right here. And all I want is a picture of, let's see, I can cut those out. All I want is a picture of this. I just want this positive going, V out positive minus V out negative. So this is what I want for question 8 right here. So that's pretty much it for this video. Good luck. Let me know if you have any questions.